3 men and 8 machines can finish a job in half the time taken by 3 machines and 8 men. So here we have some relationship between the efficiencies of men and machines. And if 2 machines can finish the job in 13 days, then how many men are needed to finish the job in 13 days? So we have a question that we need to answer, but for that we need to be able to convert the man into machine or vice versa. So let me quickly discuss with you one of the concepts, and it's really an important concept. In all the work related questions, we come across these 3 variables, M, T, and W. Let me quickly define what M is. M is either manpower, or we can say M is the machine power. Now, T is the time needed to finish the work. And work is amount of work to be done. Now, when we have understood that what is the meaning of these variables, now we are going to discuss a few questions. The question is that what kind of relationship do we have between M and W? Whether it's directly proportional or inversely proportional, let me quickly explain. The directly proportional relationship means that if one thing increases, then the other thing also needs to be increased. That is called directly proportional. But for an increase in one, if the second variable has to be decreased, then it's called the inverse proportionality. So we see that greater work requires greater manpower and less work requires less manpower. Therefore, men and work are directly proportional. While if we look at M and T, then greater time requires less manpower and less time requires greater manpower. That means M is inversely proportional to time. We combine these two relationships and we get M is proportional to W over T. Now we remove the proportionality sign, so the constant of proportionality comes into picture, and this relationship can further be simplified as manpower into time upon work is equal to constant. Now, let me quickly explain how to apply this concept. One thing is that it's a universally applicable concept. We apply it in this way, that in the first case, M1 T1 over W1 will be same as the manpower in the second case, the time in the second case, and the work in the second case. That's how we apply this concept. So let's quickly look at this question and simplify this. 3 men and 8 machines. We have several men and several machines. Let's assume M1 is representing the number of men and M2 is representing the efficiency of machine, the efficiency of men and efficiency of machine. So 3 men, that means 3 M1 plus 8 machines, that means 8 times of M2, can finish a job in half the time. Let's say the time taken by the other group is T, then they take T by 2 time to finish one job. Then 3 machines and 8 men, that means 8 M1 plus 3 M2, because we have 3 machines and 8 men. They take T time to finish the same job. So we have this relationship here. Let's quickly simplify this. Cross multiplication is to be done here. So we can write 3 M1 plus 8 M2 is equal to 16 M1 plus 6 M2, which gives us 2 M2 is equal to 13 M1. That means 2 machines are equal to 13 men. 2 machines are as efficient as 13 men. That's the relationship we have been able to arrive at. Now let's see the next information. The question says that 2 machines take 13 days to finish the job. Then how many men can finish the job in 13 days? Because 2 machines are equal to 13 men, therefore the time taken by 2 machines should be same as the time taken by 13 men to finish the work. And because we have to get the work done by men in 13 days, that means the number of men needed should be equal to 13. So all we needed to do in this question was to convert the efficiency of machines into men or vice versa, and now we have a clear answer that 13 men will be needed to finish the work in 13 days. I hope that helps. That's a very useful concept, and as I already mentioned, let me repeat that this concept is universally applicable. Thank you so much for watching this video.